friends, my name is Rahmadinni Lasonia Putri, or usually called Dini. In this video, I will discuss interesting material about energy effort and its relationship. In the world of physics, the concept of effort energy plays a major role in understanding how force of movement and shape change in systems. The objective in this video are 1. Explain the meaning of effort energy. 2. Discuss the concept of effort and relation with the system energy. And the 3 is exploring the concept of energy and knowing the types of mechanical energy. I hope you enjoy the video and let's start the discuss. First, I want you to see this image, alright? You have seen the kids with a box. Can you determine which student push the box? Let's see. The student will move from left to the right to the track with the box. So we conclude that student A made a real work to move the box from its original place. In the other hand, student B did not move at all from this place. So the box remained in this original position. Therefore, we can conclude that student B did not make any work in the box. Now, from the definition that we can conclude that work is a form of displacement of an object as a result of the force applied on the object. In the physics, effort is determined as the force times displacement. The two concepts, force and displacement, determine the work amount of work, both in magnitude and direction. One of the force or displacement value is 0, then it's considered that there is no work. Object can move because of all force applied in direction of displacement. In this context, there are two conditions described in the physics. The first one is when the force is directly proportional to the direction of displacement, and the mathematically effort is formulated by weight is W is equal to V times S. The W is work in the joule, V is the force in the Newton, and the S is the direction in the meter. The second one, when the force is applied at the angle of the object, physically the dot multiplication between two vectors, force vectors, and displacement vector, says that what it means is the projection of the force in the direction of displacement. In calculation, it is written as W equals V cos S times S, where the V cos A is the projection of direction in the displacement direction, and the A is the angle between the displacement and the force, and thus the work is positive if the force is direction of displacement, negative work is the force is opposite of displacement, and the zero work if the force is perpendicular to the displacement. Oh, now that effort is not just the distance of displacement applied by force, but how does effort usually come about? Let's take a simple example. And when we push the box and then we feel tired after pushing, how exactly did our hand work to move this block? However, the question may be deeper. How does motion actually occur? What does an object have when it's in motion? So, in the world of physics, energy is basically the ability to do effort. And when we push a box, our hand makes an effort by transferring energy in the box. The energy we interchange the text of box from the stationary to moving. However, it is important to remember that energy is neither created nor destroyed, but rather changed the one from to another according to the law of conservation of energy. Why do you feel tired after pushing the box? This is related to the concept of energy as well. The part of the energy we put in the box turn into the heat energy, and the friction between the box and the floor, and the frictional force in our hands. Hence, some of our energy turns into form of this. It is difficult to convert back cause tired. In the discussion of physics, energy is generally defined as the ability to do effort. Energy related to motion is kinetic energy, potential energy, and mechanical energy. And the first one is kinetic energy. Kinetic energy is usually like the spirit possessed by an object in motion. Imagine, the faster the movement, the greater the kinetic energy it has. Now, we can find this kinetic energy in various types of movement, from the strike motion, parabolic motion, circular motion, and vibration motion. To give us more vivid picture, let's observe the motion of coconut falling from its tree. There are two interesting positions that we notice, namely position A and position B. The question is, Where is kinetic energy from coconut grater? If you answer B, you are right. Why? Because coconut falls, its heat continues to increase. So when it reaches the point B, the kinetic energy is much greater than at point A. Now let's explore the kinetic formula. The kinetic energy formula is AK equals half mv squared, when the AK is the kinetic energy in joules, m is the mass of object in kilograms, and v is the speed on meter per second. So, the greater mass of the object and the faster it moves, the greater kinetic energy it has. Now we begin the second one is potential energy, where an object has some sort of hidden to its position. Imagine when the coconut falls from the tree, it has potential energy too, due to the difference between position A and position B. At the position A, the position is higher, so the potential energy is greater than compared to point B. At the point B, the position is higher, and so it's more greater than point B. To differ, let's try to understand the formula for gravitational potential energy on the surface of the Earth. The formula goes like EP equal mgh, where the EP is gravitational potential energy in joules, m in the mass of object in kilograms, and the g is the acceleration of gravity in the surface of the Earth, and h is the height of the object above the ground. Oh wait, let's forget not about the third one is mechanical energy. Mechanical energy is the combination of kinetic energy and potential energy. The formula consists EM equal AK plus EP. Alright, we already know how about the words and the energy means, so I will give you an example of the video of the skateboard player to play, and you have to determine on how the energy and what to do in the skateboard, and we will can experiment at the lab simulation in the pad simulation to know how does the kinetic energy and potential energy works in the game of skateboard game. Check it out. Okay, first you have to open the link that I give in the pad simulator energy skate part, and you can play the button, wait for the loading, and there's a 4 menu. The first one is intro, and you can drag the player in the track, and you can check the pie chart and the graph in the order to know how the energy does work, and the speed in the player skateboard. Now you can see how does the pie chart change the track. You can see, you can stop the motion in case you want to focus in how does the pie chart and at the position, and you can various to make just in how the track make it, how the shape of the track, and how does the player appearance is the measure. And this menu you can measure how the energy in the potential, kinetic or thermal total energy in the each of height and the track and the player, and you can do various to the mass and the gravity in the player, and you can see how the change of the kinetic energy and the potential energy in the various of mass and gravity. And the third one is the graph. In this menu, you can see how the graph in the each of kinetic, potential, thermal, and the total energy is the movement of the skateboard player. And the last one is the playground. Is this you can create your own track in the player, and you can see how the kinetic energy and potential energy do in your track. Alright, maybe that's all our video. I'm sorry for any mistake about how the words and energy does mean, and I'm sorry for any mistake. I hope you enjoy my video, and thank you for watching. Bye bye.